Radian measure is something that is extremely important in trigonometry, and a lot of students fail to remember what the definition for the radian is. And the definition is right here, where your theta in radians is equal to the arc length, which is S, divided by the radius, which is your R. So if the arc length and the radius were equal, then S divided by R would be 1, and your radian measure would equal 1 unit. Now there are some common radian measures around the circle that would be easy to know. First of all, if this is 0 and the radius is 1, you would know that the circumference is equal to 2 pi r, or if the radius is 1, it's equal to 2 pi. Now, the circumference would be 2 pi, but when you're talking about the angle all the way around, it would be S over R. So the angle would equal 2 pi divided by your radius, which is 1. So theta equals 2 pi. All the way around the circle is 2 pi radians. Notice I don't really label it with radians. It's assumed that it's in radians, and degrees would always have the circle as the label. So all the way around is 2 pi. That means half a way around is pi. A quarter of the way around is pi over 2. And 3/4 of the way around is going to be 3 pi over 2. I'm just having the amounts as you go through. I could have this one as well from 0 to pi over 2. I'm getting pi over 4. And if I added pi plus pi over 4, I'm going to have 5 pi over 4. Now notice I'm going from the positive x-axis in rotation counterclockwise. That's going to mean it's in standard position. And so in standard position, you have the initial side and the terminal side, and you're going to go again counterclockwise. Now, as you saw before, that 180 degrees is the same thing as 100 as pi radians. And so that's going to be your conversion back and forth. So you're either going to multiply by pi over 180 when you convert, or multiply by the other way around. Now, one idea is also called a coterminal angle. A coterminal angle is angles with the same side, with the same terminal side. So you can see in this diagram, this angle in standard position is going to have the same initial and terminal side as the green one, except you're going in opposite directions. This direction is positive. When you go clockwise, it's actually negative. So the coterminal angles, 120 degrees and negative 240 degrees, are a pair, coterminal pair. You could also have 0 and 360, or even 30 and a negative 330, 10 and a negative 310. Now notice what's happening here. When you add up these numbers and forget about the signs, you're always equaling 360. So in other words, 350. So in other words, what you're going to have is the absolute value of one terminal angle plus the absolute value of the second coterminal angle is always going to be 360 degrees. Talks about multiplying by pi and 180. So to do a couple problems, converting degrees to radians, you would multiply by pi over 180. Notice that you have the degrees that cancel again. And so let's see, to simplify this, it would be minus 25 times pi over 18. And you can't simplify that anymore. I took a 10 out of the top and the bottom. Negative 25 pi over 18 radians, no label. Same thing here, pi over 180. Degrees cancel, you're left with radians. 6 goes into 180 30 times, so you're left with pi over 30 radians. Converting the other way, you're going to multiply by 180 degrees per pi radians. Notice there isn't a circle here, so you know it's radians. Pi's cancel, and you're left with 720 degrees. Again, one more quick example, 180 times pi. And again, you're looking at canceling the radians. So the pi's would divide out. 30 goes into 180 6 times. And so you're left with 78 degrees for your answer here. A lot of cancellation going on. And so that's the definition of a radian. It's how to convert from radians to degrees and its standard position as well as coterminal angles.